Lesson 89 is about value problems, and these will be similar to the coin problems you learned about in Lesson 83, except you won't be dealing with coins. You might be dealing with like tickets, for example. And say a ticket cost $5, so you could say for its value 5 times T. Just like if you were talking about nickels and you wanted to talk about the value of the nickel, you'd say 5 times N. Let's go ahead and do a practice problem. Let's just read it through once. Good seats cost $9. Other seats cost $5. If 21 tickets were purchased for $137, how many were good seats? So we want to know how many good seats we had. We don't know how many other seats we had either, but they just want to know one thing here. How many were the good seats? So we solve this and we set it up just like a coin problem, and we'll have two equations and two unknowns. One equation will deal with the value, the other with the quantity. Let's start with the quantity. We have 21 tickets that were purchased. So we could say G for good seats, and then we had other seats. O wouldn't be a good variable to use though, because that looks like a 0. So let's just call it seats. We have good seats and then just seats. The total of those was 21. Now let's do the value problem. The good seats cost $9, so that would be 9G, and then the other seats cost $5, so that would be plus 5S, and they totaled up to 137. And all of our units are in dollars here, so we don't need to change any decimal places or anything, because all the units are in dollars already. Let's do substitution to solve this. I'll just go ahead and solve for seats on the top. And I'll say S is equal to 21 minus G. And by solving for seats, I can just substitute that in to the bottom equation, and I'll have one equation just in terms of good seats, which is what I'm trying to get. That's the question I'm trying to answer, is how many good seats there were. If I would have solved for good seats in the top equation, then in the bottom one I would have had to solve for seats first, then go back and solve for good seats. So this just saves a step. And you might just do a little bit of thinking before you start solving it to help you save a step. So let's go ahead and substitute that in. 9G plus 5 parentheses 21 minus G is equal to 137. Go ahead and expand that out on the left. 9G plus 5 times 21 would be 105 minus 5G is equal to 137. And so I can add the 9G and the negative 5G on the left, and I'll have to write the equation over here to the right because I'm running out of room down there. 4G plus 105 equals 137. Subtract 105 from both sides, and we end up with 4G is equal to 32. And so the number of good seats is 8. G equals 8. And so there's our answer. So these problems are very similar to the coin problems. You just have to apply a value to like tickets or cost of an apple or an orange or different things like that. Let's do one more. Apples cost 10 cents and bananas 7 cents. If 20 pieces of fruit were purchased for $1.61, how many pieces were apples? So we just want to know one unknown, apples, but we don't know how many bananas there were either. So we have two unknowns here. So we'll set up two equations dealing with value and quantity, just like we always do on these value problems. Let's do our quantity one first. We have 20 pieces of fruit. So we can just say A for apples plus B for bananas equals 20. And then we have a value problem to make. The apples cost 10 cents, so we can say 10A. The bananas were 7 cents, so 7B equals the total of the fruit that was purchased was $1.61. We need to change that to cents though. 161 61. Now that value equation is all in terms of cents. So we want to figure out how many pieces were apples. Let's go ahead and solve the top equation for bananas. If we do that, we can substitute in for bananas in the bottom one, and we'll have an equation just in terms of apples. So we'll say B is equal to 20 minus A, and we substitute that into the bottom equation. 10A plus 7 parentheses 20 minus A is equal to 161. So now we have one equation with just one unknown, apples. And now we can solve for apples. 10A plus 7 times 20 is 140 minus 7A is equal to 161. Simplify on the left, and we would have 3A plus 140 equals 161. Subtract 140 from both sides. That cancels on the left, and we have 3A is equal to 21. And so that means A is equal to 7. So that's our answer. 7 apples. We could quickly figure out bananas too. 20 minus 7, there'd be 13 bananas. So 7 apples were in that group that was purchased. Okay, well that's all for lesson 89.